Hey everyone, so my name is Kautuk, and we kind of benchmarked a bunch of different zkVMs, and just like I'm trying to present like what we found out. So the motivation behind that was we wanted to find a way to prove Stackr state machines wasm that we used to generate, and we did not really have like a good way of proving those things. But that evolved into a general curiosity to explore the other options that we have to prove that. And there was no objective comparison between the nuances of the available options. And in general, we were having a lot of fun working on these zkVMs. But oh boy, there are a lot of zkVMs now. And in fact, within 2 blocks, there are two of the zkVMs project right now, just at the Salesforce Tower, the Nexus team. This is the current landscape that looks like right now. So we have SP1, we have Res0, Nexus, Valida, Joel, zkM, Delphinus, Fluent, Ligero, even Polygon is going to have one. And if we add more protocol specific ones, there are even more. So Skyro, Aztec, Maiden, Mina, and a few more. And I don't know what the fuck. So we kind of like reduced our scope to a couple of them, which was I think 6 of them. So SP1 is 0, Nexus, Valida, Jolt, and Delphinus for WASM specific things, and that is what we would be talking about. But like I could want, if I want to, I can say that zkVMs are the new L2s. Why? Because there are more zkVMs than there are zk apps. I'm not sure if that's a good thing. So these were the benchmarks that we wanted to work on. So developer experience, how the docs are, how the support of the community is, what the code looks like, what's the happiness quotient is. That's like the most important factor for us. If we are happy writing that particular code, what the features the zkVMs provide, and ultimately the most important one, which the performance of these. We wanted to create a test suite that creates an almost level playing field for all the test candidates. This is not possible for all of them because some of them are targeting RISC, some of them are targeting MIPS, like some of them targeting WASM, but we tried to maintain like a general area around that. We tried using commonly used operations in crypto space, so getting away with just Fibonacci and adding 2 numbers. We kind of wanted to do more about it. And we wanted to run these things with and without optimization, and sometimes just to have fun and be more sadistic, we just threw like a few WASM files to it to just see how that goes. And we use cycle count as the key metric. However, this is also not like very consistent because WASM's cycle count might be different than RISC cycle counts. These were the tests that we ran. So nth prime, ECDSA verification, BLS verification, BLS aggregation, Keychack, Poseidon, Merkle generation, Merkleization, and Merkle inclusion proofs. And these were like the different set of operations that we did on it. And it's about to get a lot risky because the numbers might be something that could be. So we scored a different bunch of different zkVMs on a score of 5. These are all like subjective scores based on what we did, but through in a couple of objective ones as well. So in most of the tests, SP1 kind of like worked the best. It's not because they gave us an office as food to eat every single day, but it objectively made a lot of sense to use SP1 for a lot of different things. So the docs were great. RISC0 had slightly better docs than SP1, and Jolt also came close, but the other ones were not so great. In terms of technical support, we were literally in the SP1 office, so we got the best support. But besides that, the other ones were also great. So Jolt was pretty good with the community forum. RISC0 team was slightly unresponsive, but then we realized that we added the wrong DevRel into the group, so doesn't that. And Delphinus team was the best. They like got on call with us. They literally gave us a few dedicated machines to run tests on. In fact, we tested a lot of the other zkVMs on Delphinus's machine. The code API was also pretty good. With SP1, everything just fucking worked, which is a bit weird. I don't know what magic these guys are doing. I might need to look into it a little bit, but it just works. With RISC0 as well, everything worked, and it would have been nicer if there were a little more pre-compiles than the regular ones. With Jolt, it's a memory hog. There were a lot of out-of-memory errors, but it was fine. Nexus and Valida were not so good. Valida being the worst of them because they did not have a Rust library, and we don't like writing C, at least today. Maybe it can change in the future, but yeah, that was about it. And with Delphinus, we had to rewrite a lot of WASM code based on their APIs and not like use any WASM that was available. In terms of happiness, SP1 and RISC0 were just amazing. Jolt was pretty good if it was not about the memory issues. Valida, we don't know how to feel about it. And with Delphin, it was fun working with the team. Nexus was not so great. In terms of features, both SP1 and RISC0 had like really good features. And in terms of on-chain proving as well, these were great. All the other fours did not have like a proving mechanism to prove on-chain. So you could build zk applications, but this would not be necessarily on-chain applications. In terms of performance, all of them did pretty well. So SP1, RISC0, Jolt both were like exceptional. Nexus was pretty bad. Velida did very good, but it couldn't do much. So that's what they are. And with Delphinus, the proof generation was slow, and we needed a beefy machine, but they got our job done with the WASM side of things. So let's just put them all together. I'll just show a bunch of graphs. You can feel free to check it out. We have like a whole spreadsheet that goes over all the details of all the zkVMs. It's boring stuff, but you can check it out for your next project. But these are like a few numbers. In most of the cases, like the lower number is better for all of them. So this like the graph looked like. One interesting thing to note was the cycle count increased linearly with the input size. So the more number of inputs you give, it would just scale linearly, which is interesting. Similarly, for KeyChack, we had more numbers here. SP1 with precompile performed the best, Nexus performed the worst, and all of the other one were generally in the same range. Similarly with Poseidon, and similarly with Merkleization as well. So you would see like SP1 and RISC-0 with accelerators or precompiles, they both performed equally well, and then all the other things just followed them, with Nexus being the worst performer there. So this is the link to the spreadsheet if you guys want to check out the numbers, which is this. We will be adding more stuff to the spreadsheet, but there are some nuances to it. Finally, in conclusion, like SP1 and RISC-0 are by far the most mature zkVMs to get started with, and slowly you'll start hating me as I talk more. So cycles grow more linearly with the input size. Debugging zkVM was quite a pain, and it was very time consuming. Serialization and deserialization is also a pain with all of them. And proven networks are not deterministic. So I used to think that proven networks are like the best case scenario, but these depend on the demand of the network itself. So the more zk apps get popular, the more proven network gets more popular, the slower your proving time would get, because that's how it is. Like, correct me if I'm wrong, from the DevOps team. A few learnings: zkVMs and blockchains are kind of orthogonal. We used to think that these two are tightly coupled together, but you don't always need on-chain proofs. You can have some things running in parallel, and then you can have the on-chain component of it tying those things together. zkVMs are like blockchains. General purpose VMs are a good starting point, but they are not for scale. So eventually, if you want more performance or something like that, you would end up writing your own circuits. This is something which we are considering as well. And GPU and metal support would unlock a few more use cases, for especially on the client side of things, client side proving side of things. But right now, it's not available. And it sucks to have anything client side. You need to use a proven network, but the proven network needs to provision you some compute. But that's something which is very non-deterministic. So what's next? So we would probably audit the test suite internally and get more accurate numbers. We'll share the research with the respective teams and get validation on the numbers, so that one team doesn't come after us that, hey, you ate with them, so you probably rank them better, but whatever. So we'll get it all reviewed and stuff. We'll try to publish our finding as a blog post or as a review paper, and we'll also try out some other VMs that we couldn't use right now. So yeah, that's it. I want to end it like the biggest risk is not taking any risk. And this is the error that we faced every single day, which is out of memory. All right, and hope this doesn't get out of your memory.